Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in NEET? India's leading online NEET coaching, 100% success. iit-jee. TeenEinstein.com. At TeenEinstein, we focus on NEET coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany and zoology with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry and biology for rigorous practice, concept understanding, evaluation, quizzes and thousands of videos. Limited offer, 40,000 per year. Book your class. TeenEinstein.com. Contact 99402 49720.
Hello students, welcome to the PYQ discussions on JEE advanced papers. Here I have got a problem from JEE advanced paper 1 2023. In this problem it is said, in a circuit shown in the figure, the capacitor C is initially uncharged and the key K is open. You see this figure, this is the capacitor and this is the key. Initially the capacitor was uncharged and the K is open. In this condition, a current 1 ampere flows through the 1 ohm resistor. So this is the 1 ohm resistor. 1 ohm resistor through which 1 ampere current flows. The key is closed at t is equal to t0. Which of the following statements is or are correct? Where you have been given e to the power minus 1 equal to 0.36. So these are the options. The first option says the value of resistance R is equal to 3 ohm. Second option says for t less than t0, that means when the key was open, the value of the current I1 through this 3 ohm resistor is 2 ampere. The third option says at t is equal to t0 plus, this is actually the current in the capacitor is 0.6 ampere, and for t tending to infinity, the charge on the capacitor is 12 microcoulomb. So look, when the key is open, then this part is not connected to the circuit, so no current is flowing through this. And at this condition it is said 1 ampere current is flowing through this resistor 1 ohm. So what is the voltage drop across this 1 ohm resistor? That is 1 volt. So what is the total voltage drop across this branch? That is 5 volt plus 1 volt, that is 6 volt. And see, all other branches are connected in parallel. Therefore, across each branch the voltage drop is 6 volt. Okay, irrespective of having these batteries. Alright, now once we know this, then it is easy to find out what is the current I1. So I know the voltage drop across this, that is 6 volt, and we know the resistance across this branch is 3 ohm. So what is the current? That is 2 ampere. So look, this option B is correct. Now let us try to find out what is the value of this resistor R. So look here, this battery is actually driving current throughout the circuit. So 2 ampere current is flowing through this way and 1 ampere current is flowing through this way. So can I say that the total current in the circuit which is driving by this battery 15 volt is 3 ampere? which is getting branched into two branches here. That is correct, yes. Now I can write this, look, 15 volt minus I into R, which is equal to 6 volt. Okay, therefore, so this I is actually 3 ampere, okay, through the resistor R. So now on simplifying, we can write R is equal to, see, 9 volt by I is again, so this is volt and this is ampere, so I is 3 ampere, so I get R is equal to 3 ohm. So look, this first option is also correct. Now we'll go to the last option first. Okay, the fourth option. See, when the switch is now, this key is now closed, therefore so current will flow through this capacitor also, and capacitor will start charging, and when we wait for long time, then this capacitor will have voltage across its plates, parallel plates or terminals, that is 6 volt, and we know it has capacitance 2 microfarad. Therefore the charge stored in the capacitor will be 12 microfarad into 6 volt, which is 12 microcoulomb. And this is the condition when it will be actually fully charged. Okay, it will be fully charged. Now we see another condition. So this fourth option is also correct. Now we'll see this third option. So third option says that at t is equal to t0 plus 7.2 microsecond, that means any intermediate time, the current will be I is equal to I0 e to the power minus t by CR, which is given as 0.6 ampere. This we have to cross check whether it is 0.6 ampere or not. So we know this expression, I is equal to I0 e to the power minus t by CR at any time t, where CR is the time constant, that means it has unit of time. So let us see what is this CR. See, we will get equivalent circuit at any time when the K is closed or key is closed. We'll have this, see, we'll have equivalent battery, along with that we'll have equivalent resistance. So this equivalent resistance is, see, this 3 ohm, so this, all this in parallel, okay, with equivalent battery, and then we'll have this capacitor, along with that there is 3 ohm resistance in series. So this is my equivalent circuit at any time, intermediate time, okay, when the capacitor is getting charged. Okay, so at this condition, you look, this circuit, since these are our parallel branches, and we have seen the voltage across this is 6 volt, so the voltage this capacitor is getting is actually 6 volt, okay, 6 volt. So I0 we have to find out. I0 means the equivalent or the effective EMF, so which is 6 volt here, and the equivalent resistance we have to find out, that is actually 3 ohm plus this, okay. So what is R equivalent? 1 over R equivalent is equal to 1 plus 1 over 3 plus 1 over 3, so this will be 5 by 3, and R equivalent will be 3 by 5, which is actually 0.6 ohm. So we have got 6 by 3.6. This is my current I0. Okay. Now what is this CR? CR. C is 2 microfarad, and what is this R? R is 3.6 ohm. So here also we get 7.2 microsecond. Okay. So if we put this in this equation, look what we get. I is equal to I0. I0 is 6 by 3.6 into e to the power minus 1. Okay, because CR is T is given as, see, T plus T0, that means this is T. Okay, 7.2 microsecond. And we have got here also CR to be 7.2 microsecond. So see, this value is already given. This value is given as this. So this will be 10 to this. So you get here 0.6 ampere. So look here, this third option is also correct. Therefore in this problem all 4 options are correct. So if you answer all 4 options correct, you will get the full marks, otherwise you will get part marks. So thank you for your patience.
Why waste time in commute and spend a lot of money for iit-jee coaching? Parents, do you want your kids to achieve top scores in iit-jee? India's leading online NEET coaching 100% success iit-jee. At TeenEinstein, we focus on iit-jee coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.